All right, welcome back. We're doing Shifrin's Multivariable Mathematics, and we're looking at 1.3.9 today, which is Chapter 1, Section 3, Problem 9. So we want to suppose that we have two subspaces U and V of Rn, and we want to suppose that U is a subset of V, right, or a subspace of V, right? We want to show from those assumptions that it follows that the orthogonal complement of V is a subset of the orthogonal complement of U. In other words, V perp is a subset of U perp, right? If U is a subset of V, then V perp is a subset of U. So let's go ahead and prove this. Okay, so let's let V prime be an element of V perp. Now, if you remember for proofs like this, if I take an element of V perp and I want to show that it's a subset of U perp, I need to show that that element is also in U perp. So at the end of this, I should get that V prime is also in U perp. That's what I'm trying to show. Okay, so if it's in V perp, by definition, that means that for all V and V, V dotted with this V prime has to equal 0. Remember, that's what the orthogonal complement is. The orthogonal complement is the set of all x's such that x dotted with V is equal to 0 for all V and V. In other words, it's just the set of all vectors that are orthogonal to every vector in V. That's basically it. It has to be, every vector in this V perp has to be orthogonal to every vector in V. Okay? But wait a second. If it's true that this V perp is V perp dotted with V is equal to 0 for all V and V, but wait a second. U is a subset of V. So, I mean, everything in U is in V. So if it's true for all of V, well, then it's also got to be true for all of U. So for all U in U, U dotted with V prime has to be equal to 0, right? Because this is just, if it's all V and V, well, there's more V's in V than there are, well, all the U's are also elements of V. Let me say it that way, right? So if it's true for all the elements of V and V, well, then it's also got to be true for all the elements of U and U, because this is just some V, right? This is just some element in this set here. Okay, so V prime dotted with U equals to 0 for all U and U. But wait a second, what is that set? That's the set U perp, right? Because U perp is the same idea except it applies to U and not to V, right? U perp is just the set of all elements that are perpendicular to everything in U. Well, this V prime is perpendicular to everything in U because its dot product with everything in U is 0. So then this V prime must have also been in U perp. So I started with the assumption that V prime was in V perp, and I showed that that also means it has to be in U perp, and therefore V perp is a subset of U perp. Okay, that's the end of this proof. I'll see you in the next video.